Welcome back, everybody. In our last lesson, we focused on how to visualize data using graphs. And some of the examples we used were stem and leaf plots and ogives, etc. And this helped us find trends and patterns. It helped us to compare data sets or just looking at parts of a whole. Today, we're going to shift our focus to something called percentiles. And we're going to talk about what they are, how to find them, how to rank data using them, and then also how they relate to another topic we're going to talk about, which is the 5-number summary and box plots. This is an important skill that's used a lot in real life. So you'll hear percentiles used a lot with test scores, with health indicators or health statistics, and business metrics. So let's first talk about what a percentile is. A percentile tells us how a specific value compares to the rest of the data. It's a way to rank a data value when we compare it to the rest of the whole entire data set. So let's say, for example, you're the 80th percentile for height when you visit your doctor. The doctor tells you you're in the 80th percentile for your height. What that means is that you are taller than 80% of the people your age. So it's a rank position. It's not necessarily a percentage itself, but it tells you where you rank if you list the data values from smallest to largest. So here's the official definition. A percentile indicates the value below which a given percentage of data falls. Now we have two formulas we're going to use for this. The first value, or the first formula, is where we know the percentile rank. That's your K value. And we want to find the value in the data set that corresponds to that percentile rank. Now, there are times that when you look at the data set, your answer for finding that kth percentile, it might not be in the data set, but it will lie between two numbers in the data set that's going to split it into the percentages that you're looking for. So sticking with that 80th percentile example, if I was looking at the 80th percentile for a data set, that means whatever that value is, 80% of the data lies below and 20% lies above. But that data value does not necessarily have to be part of the data set. It can be, but it doesn't have to be. Okay, now for the second formula, this is when we are, or I should say, we know the data value, and we want to find the percentile rank. That's formula 2. All right, so I'm going to walk through some examples here that will show you how to use each of these formulas. Looking at example 1, it says a geologist measures a newly discovered crystal at 4.2 inches. Use the following data to determine the percentile rank. So we have the data value, and we want to find the percentile rank. So looking at these two formulas here, that would be formula 2 that we're going to use. Use formula 2, which is x plus 0.5y over n times 100. Looking at the values or the variables of the formula, X represents the number of values below the given value. So that means X is the number of values that fall below or that are less than 4.2. So we need to count, for step 1, we need to count all values less than 4.2, not equal to, just less than. Now, if you have to sort the data, if you have a large data set, don't forget you can use the sort command on GeoGebra. And I'll show you that in just a minute as a refresher. So when we count all the values that are less than 4.2, that's going to be our X value. Then our Y value is going to be any repeats. So if I see 4.2 3 times in the data set, then Y is going to be 3. So Y is the number of values equal to the given value. So how many values do we have of that data value? In this case, I only see one 4.2. So Y in this case is going to be 1 because there is only one 4.2 in the data set. Okay, so finding X, Y, and N, those are the main things. So in step 1, we got to find X. We haven't done that yet, but we are going to. That's the number of values that are less than 4.2. In step 2, we found Y, and Y is going to be 1 because I only see one data value as 4.2. I don't see it listed more than once. For step 3, we find N, and N is the sample size, which is the number of values. Now, when we count the number of values, we have 23 values. So in this case, we would have N is equal to 23. Now, let's jump over to GeoGebra for a moment so that I can remind you on how you can sort the data so that it makes it easier to find what you're looking for. But when you're looking at GeoGebra, the first thing you want to do is you want to put your data values in the spreadsheet. So we can come over here, we can click either view here and add spreadsheet view to our screen. I don't need my graph, so I'm going to uncheck the graph. This is data that I had in there previously. If you want to save the data that you previously had in there, you can just use the next column. That's what I'll do. So pause the video for just a moment and enter your data. Okay, now that you have your data in there, we can sort it. I'm going to type in SORT for sort. I'm going to choose the first option where it says list. And my values that I typed in from this data list start at B1 and go down to B23. So I'm going to use capital B1 colon B23. And then don't forget to hit enter. And you'll notice it came up and changed my values to fractions. If it does that and you want to see them as decimal values, you can just hit this little, it looks like a squiggly equal sign. That's the sign for approximate, and it will change that back to decimals for you. So now I have all my data listed from smallest to largest. So now I can use this to quickly find all the values that are less than 4.2. That's what we need to find. We need to find our value of X. So I count all the values up to, but not including 4.2. So there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, and 16. So X is going to be 16. Okay, so we found X, which is 16. And so now we're going to put all of this information in our formula. So I have 16 plus 0.5 times 1, because y was 1. We only see 4.2 in the data set once. And then we divide by n, which is 23. And then we multiply that by 100 to change it into a percentage. So when I take 16 plus a half, that gives me 16.5. I divide that by 23 and multiply by 100, and I'm going to get 71.74%. With our XYZ homework, we typically want to enter the percentile as a whole number. So the final answer, when we round it to our nearest percentage, is going to be 72. So our percentile rank for 4.2 is 72. And what that means is when we look at the data from smallest to largest, approximately 72% of the data is going to be less than 4.2. Now let's look at example 2. It says a fruit farm measures daily juice yield in gallons. We need to find the 70th percentile for the yield. So we're going to use, since we're given the percentile and we want to find the value, we're going to use formula number 1. And formula number 1 looks like this. So the first step is to identify the percentile, and that's K. K is 70th percentile. Then we also need to identify the number of data values. There's 20 data values. So we're going to put down N is 20. And so we are going to now use our formula to calculate our position. The position is not going to be the final answer. So step 2 is find I, which is the position in the data set. Okay, so we're going to put in 70 over 100 times 20 plus 1, so that's times 21. That's going to give us 14.7. So that means if I look at the data when it's sorted from smallest to largest, if I look at the position of 14.7, which is, so it's between the 14th and 15th position. So we want to find the data value that falls between the 14th and the 15th value when it's ordered from smallest to largest. So let's hop over to GeoGebra real quick and let's order the data. I'm going to list all of my data values for this question in column C. So pause the video and go ahead and enter the values yourself. All right, now that we have the data in there, if we want to sort it from smallest to largest, I'm going to tell GeoGebra to sort. I'm going to choose the list option. And now I'm going to tell it to sort my list that goes from C1 to C20. So capital C1, colon, capital C20, and then I hit enter. Again, it gave me my values as fractions, which is fine. I'm just going to use the approximate button to change it back to decimals. So now here's our sorted list from smallest to largest. We said we were looking for the data value that falls between the 14th and the 15th position. So we need to find, now that they're in order, the number that falls in the 14th and the 15th position. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So the 14th position is 13.1. And the 15th position is 13.6. So to find a value that falls between here, we're going to use the midpoint formula to find the number that falls between 13.1 and 13.6. So we said that the 14th position was 13.1 and the 15th position was 13.6. We're going to use the midpoint formula, which is 13.1 plus 13.6 divided by 2. So when we do that, we'll get 13.35. So 13.35 is the value. So then when you look at the data list sorted from smallest to largest, approximately 70% falls below 13.35 and approximately 30% lies above 13.35. Now, the notation that we use to find a certain percentile is P, and then we have a little k down here where k is the percentile. So in this case, since we found the 70th percentile, I would write that as P70 is equal to 13.35.